welcome back. I'm continuing on with section 12.2 if you're following along in your notes. We just finished up talking about these teacher salaries. We had 27 surveyed teacher salaries. Now, I don't know how old this data is, if it's accurate or anything, so don't think about that too much. But this data with 27, this is what a teacher would make. At the lowest surveyed amount was $21,001, and we made classes, 8 classes out of that on our last video, and we counted up how many people made between $21,001 and $24,000, and there were 6 people that reported that. And then between $24,001 and $27,000, 9 people said that was the salary, and so on and so forth till we get all 27. Note that the frequencies, to kind of check your work, you should be able to add those back together, and hopefully that adds up to 27, that I got that on there right. So now we're ready to make a graph. So that's the next step we wanted to do, and what happens next in your book work is we display those on graphs. So we have 4 types of graphs that we will be responsible for in this class. The first one is called a histogram. Okay, so reading along with me, the first one, histogram, is where we take observed values on the horizontal scale and frequencies go up on the vertical scale. So we're getting ready to make this into one of these graphs. I'm going to do a histogram with this and also a frequency polygon, but I've got the frequencies up this side. So these numbers, when I counted up those categories, I'm going to write on this scale. So I've got it scaled up to 9. And then along the horizontal axis, you have the data. So I'll call this, instead of writing 21,000 to 24,000 under 1, I just put category number 1, so for salary. So I've got that along the horizontal scale. So again, the observed values are along the horizontal scale and the frequency is on the vertical scale. And then a bar is constructed over each observed value. So we'll make a bar. It's a type of a bar graph. A histogram is another word for a type of a bar graph. So we draw a bar around that as high as it needs to be. That bar can start at the beginning at the lower class limit or at the upper class limit. You can draw it this way, or you can draw it around that with a class mark in the middle. So there's different ways, but you get a bar above that number up to its observed frequency. Next, another thing which we talked about in section 12.1 is, so this can be misused or misleading, or really is just per the design of the graph. It's not always somebody's trying to trick you, but they're trying to make their point, and we just need to be aware whenever you make these type of graphs, the calibrations on the horizontal scale and the vertical scale do not have to be the same. You can count by different amounts these ways. You can start at 100 if you want. You can count by hundreds, you can count by ones, whatever makes your point most visually appealing to what you're trying to say. That's perfectly legal, allowed, following the rules with histograms and polygons. Number 2, the frequency polygon is very similar to what I just said, except we just put dots, more like we used to do with graphing. We just put a dot. Instead of drawing a bar, we just put a dot above where they match up. So we'll do both. Number 3, a stem and leaf display organizes the data similar to the above, but we can actually see the values. We write out a part of the beginning, calling that the stem, some of the digits, and then put the leaf, some of the last digits, and I'll explain that in a little bit. And number 4, the circle graph, probably the one you're most familiar with, is seeing a circle graph or a pie chart to organize data. So these are 4 types of visual displays that shows our frequency distribution that we talked about earlier. All right, so where we left off, at the top of the page, we were going to construct a histogram, and I'm also going to do a frequency polygon of this data with these teacher salaries. So if I do the frequency polygon, I'm just going to put dots like I'm graphing a point. So I noticed in this first category, $21,001 to $24,000, there were 6 observed teachers that said that salary range. So for category number 1, the salary range, I'm going to go up to 6. 1, 2, 3, 4, 5, 6, and put a dot. If I'm making a polygon, it's just a dot. Then for the next category, category number 2, salary, between $24,001 and $27,000, I'm going to go up to 9. So over 2 is up 9. Category number 3 was a 1. That wasn't very common answer. And category 4 was 2 in this data. Category 5 was back down to 1. Category 6 is at 7. Let's see, can I do this? 6 and 7. I need a graph. I need a real gridded paper. I'm not going to be perfect here. Number 7 is 0. And then number 8 is back up to 1. All right, in a frequency polygon, I will connect my dots. Let's see if I can get this in here well. Connect your dots from point to point to point. That shouldn't have went in. I probably need to scoot that over a little bit, or scoot this one back. Like I said, I need some graph paper because my eyes are crossing trying to get this exactly right. Anyway, so the frequency polygon would be you just make your dots and then you take the ends down and connect it down to the bottom of the graph. Shouldn't be hanging up there. So that would be a frequency polygon, just kind of plotting your points and then drawing, connecting your dots as you go across. So that's the polygon. And probably what you're more used to seeing is the histogram, or the type of bar graph where we draw bars around that. So instead of just making a dot at 1 was supposed to go up to 6. Let me draw this in, I can see better. There's 6. So 1 up to 6, I draw a bar around that. And then 2 was up to 9, that's 9. So for 2, we go all the way up to 9. And I said it earlier, it's kind of per design if you want to make the bar around that middle point, or if you want to start it at the beginning and make it over to the 2. That's either way is okay. It should say in the directions if you really had to do that. Most of your homework questions, though, will be multiple choice to help you kind of just look and determine which matches up. All right, number 3 should be 1, just up to 1. Not so perfect. Okay, number 4 is up to 2. Number 5 is up 1. Number 6, 7. Okay, that's where I get in trouble because I can't see perfectly there. Okay, looks like about right there is 7. Class 6, the 36,001 to 39,000 should have been up 7. So that should be, did I make it? Does it look good from your side? Okay, then number 7 is 0. And then number 8, up 1. All right, so that, I think I made it a little too tall. 1 is right here, so about right like that. So that would be a bar graph or a histogram of that data. All right, next thing. Well, let me go back to that stem and leaf before I do the example on the next page. A stem and leaf, let me talk to you a little bit more about that. That's the next type of graph after the histogram and the frequency polygon. We have the third type of graph, which is a stem and leaf. So for those salaries again, like where we had the $21,001 listed a couple times, and then maybe we had 22,000. Let me see, I better put these. We had 21,400. Sorry about that. 21,400, 21,500. Somebody made 22,000 exactly, and then 23,500. So just to show you how that would look on a stem and leaf, we would put maybe the 21 as the stem of it. And then for the leaf over here, would say 001. Then we would put 21 in front, and maybe the leaf would be the 400. So maybe the stem, and again, this is, a lot of these are per your design. There's no absolute, this is the only way to do it. You can design it to meet what you're trying to do the best. But this would be an example. The stem is part of the number, and the leaf is some of the last digits. So 21,500 would look like that, and so on. So that's a stem and leaf. All right, now let's go to the next page. So an activity, if I had you in person, and maybe we'll try to do this online at some point, I would have you practice in class, pull out some coins out of your pocket and look at the dates on that and kind of go around the room and get an idea of, as a sampling of some of the dates of coins in your pocket or in your purse. So for an example I have here is, say we were in class together and someone said they had a coin that says the year 1990, the year 2005, 1985, 2007, 2019, another 2019, a 2018, a 1998 coin, and a 2018 coin. So just some general numbers. So, and again, this would be per your design, how you wanted to do this, but you kind of look at your options you've got and figure out what the smallest one is, which is my 1985 coin. So maybe I'd make my stem 1, 9, 8. And then I'll make my leaf the 5. And then I say, do I have any other 1980 anythings? I do not. But if I had a 1986, I might put a 6 over there to add in another, or maybe another 87 or so on. But that's all in the 80s. Then I go to maybe 1990s. I see I've got a 1990, let's see, 1990, exactly, just 0 at the end. And then I've got a 1998, so I'll put an 8 at the end. And these can be in any order, actually. All right, so I had 2 different ones that ended 1990 something in that decade, so 0 and 8. Now let's go up to the year 2000, that decade. So 200 and then some different years. Let's see, I have an 05, I have an 07, so leave a little space maybe to kind of show that you're moving over, and that's all I've got. Then I go up to the next decade with a 1. I hope I haven't missed anything. I think we're okay. 2000 in the 10 decades. So we have a 19. Oh, and we got 2 of those. So I'll write 9 twice. 2018, 2018. So that was the most common because that's the most recent. So that would make sense. But that's how my stem and leaf would look. And if you think about it, if you kind of turn this on your side, it almost looks like a histogram or a bar graph because it shows you the depth of that. Like this one, I just had 1. Here I had 2. So if you kind of thought of it like that, it sort of looks like a sideways bar graph to me. But what's good about it is it's got actually the numbers in there. Instead of just having, you know, on a bar graph, we wouldn't see actual numbers. We just see how tall the different bars were. So in the stem and leaf, we get to see actual data. You can look at every single piece of data still. So I think that's kind of a neat feature of the stem and leaf. All right, next activity, again, if we were in class, a lot of times I'll buy M&Ms for the class and we'll get in groups and we'll do an M&M activity because they make for really good data, right? So you get M&Ms plus they're colored. There's different color flavor packets of Skittles or M&Ms. And if you go on the website, you can find out like the official, what percent are supposed to be brown, yellow, orange, and so on. So we do a statistical graph. You can do this at home if you want, but I'm just going to kind of talk to you about it here on the video. But we could count out our M&Ms and then do this sort of thing to them, one of our types of graphs. So kind of a circle graph is a good graph to make with your M&Ms. And you could draw in, for the circle graph, it's the most visual to me. I think it's probably the one we're most used to kind of seeing and familiar with. You know, a circle, that's the center. If you go all the way around a circle, it should have 360 degrees. So you figure out like what proportion of your data is brown, for example, and then you make a piece of this. Say if a quarter of them, of the M&Ms were brown, you would draw in a fourth of the circle, which would be 90 degrees, and we could use some of our cool math tools and actually use a protractor and a compass and draw these in. But say that a fourth of your M&Ms are brown. I can't remember what it actually is, but you'd make a fourth of your circle, which would be your 90 degrees, and say, oh, that's brown, and you can make them, usually they're more visual and they're colored in and easy to read. So in activity 9, again, if we were together, I might ask the class, what's your favorite soda or your favorite drink? So I just made up some numbers here. Let's say, and by the way, in this current class that we're in, there's 41 of us altogether. So let's say that 10 people said Coke is their favorite. I know there's a big Pepsi-Coke debate. So say 12 said Pepsi. 5 of you just like water. 8 are tea drinkers. And let's say Mountain Dew, we've got 6. So that make up 41. I just made those up. So to make a circle graph, what we would do is we'd get our total, 41, and then we'd figure out what percent are Coke and put it into our circle. Like you would need to take 10 divided by 41 and change that into a percentage, which would be about 24%. Didn't come out just exactly right, but let's average it to 24. And then you say 24% of this circle needs to show Coke as the most common as the answered question there. So 24% of the circle, well, what is that? If you wanted to be picky about it, but there's all these programs online, you can just pick a program to do this actually, but mathematically we would times that by 360 degrees to see what actual angle we should make. So when you times 24% of 360, it would be 87.8 degrees. Then we could find the center of our circle and put our little protractor on that and aim for 87, say that was 87.8 degrees. So we could get specific and do that and find each part of this. Okay, so I'm gonna say that's how many drink Coke. And then you could do the same thing for Pepsi. 12 divided by 41, that came out to be 29%. And then times that by 360, and that should be 105 degrees. So then I would work off of my edge here and put my protractor on that and line it up and then aim for 101 degrees, which is a little more than a right angle. I'm going to kind of estimate it in there and say Pepsi. But you could get that exact, and again, there's lots of apps that, computer programs that you can use for doing these type of things. So just be aware that would be the math behind it. And then just to kind of give you a visual kind of about what it would look like. And like I said, I would make it much more visual if color it with, use colored pencils or something to show it more dramatically. But you'd want the whole circle to get filled up whenever you were done. You should have accounted for all 360 degrees to display the breakout of the different types of drinks in a circle graph. All right, so I hope that helps. Best wishes.